They are just participating in the exam. So just concentrate here. Okay. So here the question that an aldehyde as well as ketone can be represented. Is this visible on your screen?
Yes, sir.
So what would be the compound this one? Can you tell me that what would be the compound for this one? So this would be, it is saying that an aldehyde as well as ketone, it is also mentioned here. Represent the same molecular formula, this one. Write the structure and the name. So the structure, you know that it would be, the structure of this one would be, you can make it like this way. This will be prop anion. Okay. And this one will be aldehyde like this way. And this will be prop anal. Prop anal. Okay. You understood? Yeah. Some of the question that we have discussed in the previous class also. So let's move from 40. Okay. Got it? Next question that I have given you is question number, uh, after 40, we have 41 questions. Okay. 40. This is most important question that comes in the examination. What is mean by isomers? What is mean by isomers? Can you tell me? What is mean by isomers? Adil, Jobita, Jaslin, Tejasvi, Shweta. Can you tell me that what is isomers?
Compounds which have a same chemical formula but different structural formula is known as isomers.
Yeah. And so here we need to understood that the isomers are the compounds that are having the compounds of hydrocarbon that are having the same molecular formula but different structures. Okay, they are called isomers. What are isomers? The compounds having same molecular formula but different structures are considered to be as isomers. Okay. And it is asking that draw the isomers of butane. So I think every one of you will be able to draw the isomers of butane. Is it it is difficult for you or not? Tell me.
Yes.
This is very simple. Isomer butane has only two isomers. One is N-butane, normal, like this way, CH3, CH3, CH2, CH2, this. And what is another one is? Yes, 2-methyl, 2-methyl propane. Got it? So every one of you, I think that explain why we cannot have isomers for first three members of series. So it is asking that why it is not possible, because rearrangement of carbon is not possible. Now, for the if there are only three carbons, then there will be only one kind of chain is there. Even if you break this one, then if you like this one, this will be also having one chain. You understood? Are you getting my point, everyone? You, Jobita, and everyone.
Yes, yes, sir.
Yes, sir. Okay, so this is not possible because the rearrangement of carbon is not possible. If we are having less than four carbons, okay, exactly four and above are going to have isomers, okay, but we can have the functional isomers. Just you need to concentrate here, dear students, that we can have the functional isomers. Okay, let me explain you that what is functional isomers. The isomers having same molecular formula but different functional group. There we can have less than, if we are having less than 3 carbon, then it is possible. Sorry, less than 4 carbon, then it is possible. Like in the above one. above one, this formula C3H6O, okay, C3H6O, it is going to have the same, let me share the, just a minute. Let me explain it here. I will take one by one each and every questions, okay, and then I'll put this one there, okay, just a minute. So here you can see that let it is possible for the, if we are having less than 3 carbons, okay. So here it is, functional isomerism is possible, okay, you can check it. This is propanone, and if you are having this, they are having two different functions, okay. So these are the two different compounds, even having different functional group. So they are the isomer, they both are functional isomers, okay, functional isomers. So in your syllabus that we are having, ketone and aldehyde shows for functional isomerism, show functional isomerism, and even it should have C3H6, like it example. But here general formula is CnH2nO. For ketone and aldehyde, general formula where N should be greater or equal to 3, because ketone is not possible if there is less than 3 carbon, okay, greater or equal to 3. And similarly, carboxylic acid and ester, carboxylic acid and esters also shows functional isomerism, functional isomerism.
Good evening, sir.
Good evening. Isomerism, okay. So they also shows the functional isomerism, and the general formula is CnH2nO2. Here it is just a difference, here is only single O, here is double O bus. Like for example, if I have, like for example, if I'm having C3H6O2, so it can be a propanoic acid. It can be a propanoic acid. You can check it. C double bond O, OH. You can count C3, H1, 2, 3, 4, 5, and one here H6, and then O2. O2, here is one O1O. This is propanoic acid. Propanoic acid. Okay. And similarly, if I took an ester, CH3, C double bond O, CH3. So this is methyl ethanoate. This is methyl ethanoate, and it has general formula C3. You can count 3 here hydrogen, 3 here 6 hydrogen, and 3 carbon and 2 oxygen. So they both can have this. This is an ester. And name formula for this one, and name for this one is methyl ethanoate. So the compressed formula for ethanoic acid, sorry, carboxylic acid and ester could be same. You understood? Understood? Tell me
Yes,
fast. Okay.
Yes, sir.
The next question that we were having, just a minute, let me copy this one here. The next question after 41, we were having 58, question number 58. Here we have question 58. It is asking that give reason the following. Acetylene burns with sooty flame. So this is a very simple question that comes in your examination, and you all are familiar with this one. That acetylene is a gas which is known as ethine, and this is CH when it is 2 carbon. So say, okay, ethine means 2 carbon, so C2H2. You know that it is an unsaturated hydrocarbon. So when it burns in open air, then it will burn with sooty flame, because it is an unsaturated hydrocarbons, and open air could not fulfill the sufficient amount of oxygen to make it completely burns. Okay, so when it burns in open air, it gives you unburned carbon particle plus carbon dioxide plus water. And this unburned carbon particle, carbon particles make the flame sooty. Make the flame sooty. Okay. So this is the unburned carbon particle that is making the flame sooty. Because you know that this is the unburned carbon particle. Unburned carbon particle. This make it sooty. If you have something like if it is burning in open air and it is providing you sooty flame, if you have something that can absorb this burning unburned carbon particle, then these flames will appear to you blue. These particles that are not burning is making this flame sooty. And why it is not burning? Because this is an unsaturated hydrocarbon. Open air oxygen could not fulfill the requirement of the oxygen that is being required to burn it. So open air oxygen can't fulfill the requirement of oxygen of ethine to burn it completely. Okay, another question that is being asked on that why do welders use an extra supply of oxygen? The same question comes in examination, and that we have written in the copy and the notes, that why do welders use an extra supply of oxygen while they are burning the while they are using acetylene gas. It is a common name. Acetylene is the common name. Acetylene gas for welding purpose. So you know that acetylene gas is an unsaturated hydrocarbons. Again, acetylene means ethine gas. So if it burns in open air, it burns with sooty flame, providing you carbon dioxide, water with incomplete combustion will take place. Incomplete combustion means the amount of heat that is being required will not be provided. So we'll say it is incomplete combustion is taking place because of the unburned carbon particles. So when we provide an extra supply of oxygen, extra supply of oxygen, then what is going to happen? Then it will completely burns with no residue of unburned carbon particle, and the large amount of heat will be produced. Large amount of heat will be produced that is sufficient. Okay, large amount of heat will be produced that is sufficient to melt the metal for welding purpose, because you cannot melt the metal with candle, na? Like candle is burning. So same like the candle burns, the acetylene gas burns in open air with lot of black smoke. Okay, and of unburned carbon particles. So if you think that this open air oxygen can fulfill the requirement, no, we have to provide an extra supply of oxygen. Then it will burn completely, then large amount of heat will be produced, and this large amount of heat will provide the sufficient temperature that is being required to melt the metal for welding purpose. Now you understood that why do welders use acetylene gas for welding purpose? Everybody in the class?
Yes, sir.
Is there any doubt? No?
No, sir.
Okay. So let's move for the next question. Next question that I have given you after 58 we is 62. Just a minute. Let me find out 62 questions. Questions. Question number 62. Yeah. Is the chemical properties now comes? So here the question number 62. So how will you do this one? Question number 62. So here it is that what happens when 5% alkaline KMnO4 is added drop by drop to warm ethanol taken in the test tube? State the role of alkaline KMnO4. This is so many times the question is being asked for the alkaline KMnO4. And let's talk about. You know that ethanol, any alcohol, any number of alcohol, if you are talking about alcohols, when they are burning, sorry, you know that alcohol's properties we have discussed, okay? This is the very first property, that alcohols when added to alkaline KMNO4, alkaline KMNO4, then the complete oxidation will take place. Okay, and it will gives you carboxylic acid plus water. If we have 2 carbon alcohol, then it will gives you 2 carbon carboxylic acid. If it is 3 carbon alcohol, it will gives you 3 carbon carboxylic acid. So how much, what is saying that it is ethanol. Ethanol means eth means 2 carbon. So it is 2 carbon alcohol. That is C2H5OH. So when you add it, it will gives you an extra supply, means oxygen. That is, we are not writing is O2 because it is not the molecular oxygen. It is called nascent oxygen. Nascent oxygen. That is given by alkaline KMNO4. Alkaline KMNO4. It will convert it CS3COOH plus water. This is the complete oxidation. Complete oxidation is taking place. Okay. If the incomplete oxidation of alcohol take place, then it will gives you a aldehyde. Like for example, if we have C2H5OH, and if we add it to CrO3, chromium oxide, then it will gives you 2 carbon aldehyde, CS3CHO plus water. Okay, now you need to keep in mind that this is the incomplete oxidation. Incomplete oxidation. Okay, so when incomplete oxidation take place, the reagents we are changing. If we add alkaline KMNO4, it will gives you carboxylic acid. If we have chromium oxide, then it will gives you aldehyde. That is ethanol. Ethanol. So the question comes here is that what is the role of alkaline KMNO4? It is acting as an oxidizing agent, not as a catalyst. So many times this question is being asked. They will ask you in different manner that what is written on the arrow, what is the role of this substance. So it is acting as an oxidizing agent. Oxidizing agent. Why it is not? If I ask you that, why it is not acting as a catalyst? What is catalyst? Can you tell me anybody in the class that what is catalyst? Anybody in the class? Can anybody in the class tell me that what? Good. Can anybody tell me?
It increases the rate of a reaction without itself undergoing a reaction.
Yeah, this is very important. Yeah, very good. Anything that increases the rate of the reactions but do not participate in the reaction is called catalyst. For example, in the hydrogenation reactions, like you see that we have when we have alkane, alkene, like C2H4, ethene. When we pass hydrogen gas to it in the presence of nickel, palladium, and platinum, then it will gives you it alkane, and that is of ethane. Ethane means we have like C double bond here H, okay, and we pass hydrogen gas to it. Then it will gives you nickel in the presence of nickel, palladium, or platinum. You can take anyone, okay. It will gives you alkane, 3 carbon. Single bond will be there now, okay. And here in this one, these are acting as a catalyst, okay. But why? Because they are not participating in the reaction. They are fastering the rate of the reaction. Here in this one, it is acting. Here in this reaction, it is acting as an oxidizing agent. The proof of this one is that the color of the solution changed. Because alkaline KMNO4 is purple color. Purple color. Okay, when you add it, and then it changes to colorless. Indicating that it is being utilized because the color change. If at the end, like this is the question also comes. Like I'm jumping it on the life process question, that in the plants, how can you prove that chlorophyll act as a photolytic absorber or photo absorber, but not as a catalyst. Okay, but not as a catalyst, because you know that if it act as a catalyst, okay, then okay, we will simply say that it will absorb the light. But if it is absorbing, green color substance is being utilized now. Let's come to the don't go there. The process will increase and the time will increase. So let it be. Just I'm just want to explain you that here it is not increasing the means the color is changed. If the color change means it is not acting as a catalyst because it color change. Even the catalyst will be at the end of the reaction. They may be utilized in the reaction. Okay, in intermediate, they may be utilized, but at the end of the reaction, the catalyst will be obtained at the same color, same state. If it is solid, so the solid catalyst will be obtained. If you add it in the powder form, it will be obtained in the powder form. If you obtain in the liquid state, it may be utilized in the in between. Intermediate, it can be utilized, but when it is being utilized in the intermediate, it's okay. But at the end of the reaction, it should be in the same. Okay. So similar, if the chlorophyll is being used as a intermediate, so the color of the leaf should change when it is being utilized for some time. And when the light fall on the leaves, it will be absorbing the light, but the color does not change. So it means that the chlorophyll does not act as a catalyst, because in intermediate it is being utilized, but at the end of the reaction, it will be in the same color. So same is for this one, that it may change the color purple, then colorless, then again if it is used as a catalyst, then it should be purple color at the end. But no, it is not the purple color. It gives colorless color permanently. So it means it is being utilized. Got it? Everybody in the class utilize? Oh, sorry, understood? Tell me fast.
Yes, sir.
Yes, sir.
Abdullah, and
Yes,
you,
sir.
Adil, and Jobita, Tejasvi, Kiran.
Yes, sir.
You understood? Kiran, you understood this concept? That why it is acting as an oxidizing agent? The same reason that its color changes. That's why it acts as an oxidizing agent. Okay. Next question. If I took the next question. After this question number, which was the question? 62. After 62 is 64. X and Y type questions generally comes in the examinations, and I used to send you every day the X and Y type questions. So it is must that you must prepare those questions properly. Okay. So here, what you say about this one? Two carbon compounds X and Y have molecular formula C4H8 and this one. Okay, respectively. Which of the following most likely to show the addition reaction? Tell me, which of the following will show the addition reaction? Addition reactions are shown by? Tell me, Jobita, Jaslin.
Alkenes and alkynes.
Alkenes and alkynes means unsaturated hydrocarbons. Na?
Yes, sir.
So if we have unsaturated hydrocarbons, then they will going to show the addition reaction, because in addition reaction, we are adding something. Na? Like for example, this is an addition reaction. This is an alkene and you've passed the hydrogen gas to it. So this bond will break and it will gives you okay, this bond will break and will gives you like this way. Okay, so this will show the addition reaction. This is an addition reaction because there should be an unsaturated hydrocarbon should be there. So you know that this is unsaturated hydrocarbon because it is having C and H2N. You put NS4, so double of this one is 8. So C4H8, it is a formula for the compressed formula or general formula for the alkene. So Y will show the addition reaction and justify your answer, and also the chemical equation to explain the process of addition reaction in this case. So you can explain it by using this equation. Okay. You understood?
Yes, sir.
Is there anybody in the class who didn't understood this, didn't get this question? Do everyone understood? Tell me fast.
Yes, sir.
Yes.
Yes, sir.
Yeah, simple question. Huh? This is not a tough question. After 64, we have 67. We have done so much advanced level questions. Uh, every day I used to send you 67. The electron dot structures generally comes with the examination. So electron dot structure must be there. Okay, so if we took this one, Here is the question. So it is saying that draw the electron dot structure of ethyne. Ethyne. So ethyne is triple bond. A mixture of ethyne and oxygen is burned for welding. In your opinion, why can't we use the mixture of ethyne and air for this purpose? So this we have discussed. This portion we have discussed that if you burn it on open air, then it will burn with sooty flame, which will not which is considered to be as an insufficient means incomplete combustion, and will not provide the sufficient amount of sufficient amount of heat that is being required to melt the metal. So that is very important. Sufficient amount of heat that is being required to melt the metal for welding purpose. This is an important line for this answer. Okay, electron dot structure of ethyne is very simple, that you can make, you know that ethyne is CH triple bond CH. So you can make it like this: C, 1, 2, 3 carbon here, and electron, one hydrogen here, and one hydrogen here, and one electron of carbon is here. Okay, just you know that this complete the duplet, this also complete the duplet, and this will complete the octet. 6 here and 4 6 and 2 8. Yeah, it should be like this: one carbon, like this way. You understood now? Understood, everybody?
Yes, sir.
1 2 3 4 5 6 7 8. So 8 has been placed here. Okay, so this is the electron dot structure of ethyne. Next, question was after 67 we have 77 and then 78. 77. So in this questions, what you will write? What is a write the respective chemical equation to show what happens when ethanol is heated with concentrated sulfuric acid at 443 Kelvin. So this is the property of ethanol, that ethanol when burns C2H5OH ethanol, and it is capped with concentrated H2SO4, then you know this is the dehydration reaction will take place. Okay, just water will be removed from here. So you know the water is HOH. So this OH group and one hydrogen from this one will be removed. So it will be C2H4, and double 2 carbon double of this one will be ethene. Okay, got it? Got
Yes,
it?
sir.
This is very simple reaction. And ethanol, next question is for the same is ethanol react with ethanoic acid. So ethanol when react with ethanoic acid in the presence of acid as a catalyst. Here it is used as catalyst. Okay, when it is reacting with ethanol, C2H5OH, and when we have CH3COH, ethanol is reacting with ethanoic acid. So what it will gives you, tell me? CH3COO, C2H5. Okay, just keep in mind that here the total number of carbon is 2, and here it is total number of carbon is also 2. So the total number of carbon here should be 4. 1, 2, 3, 4. Okay, so this type of question is being asked in the examination. It is acting as catalyst or dehydrating agent. Okay, so here you can say what's the name of this one? It should be ethyl ethanoate. Ethanoate. Why? Because like this, if I write CH3COONA, the name of this one will be sodium, and the group 2 carbon eth and O8. Okay, COO group is considered to be as O8 group. Got it? Understood? Tell me fast. Is there
Yes,
any
sir.
doubt?
Yes. No, sir.
Okay, if the question comes to you that let's suppose take a question of this one, like we have C2, that we have a carboxylic acid C3H6O2. This is a carboxylic acid, double of this one. When it react with an alcohol, let we don't know the name of this alcohol, in the presence of concentrated H2SO4, it forms a sweet smelling substance with a formula of C5H, H double of this one is 10 and O2 plus water. Can you predict that the name of this alcohol? Can you predict the name of this alcohol? It's very simple. This is an ester. Compressed formula is of ester and carboxylic acid is same. That is CnH2 and O2. Can you tell me?
CH3COH.
C2H4O2.
No. Yeah, C2H4O2. No,
Yes.
C2H4O2. No, it is an alcohol. It does not have O2 formula. Alcohol I'm asking. This is carboxylic acid, 3 carbon carboxylic acid. So you know that this is very simple. That I was just trying to explain you. That if this carbon has, this is a 3 carbon compound and this is a 5 carbon compound. So where the 2 carbon comes? The 2 carbon should come from the alcohol, na? 2 carbon alcohol is C2H5OH. You can check CH3, CH2, COOH. Ethanoic acid, when you have C2H5OH alcohol, then it will gives you CH3, CH2, COO. This group will come from the carboxylic acid and this group will comes in the ester from alcohol. Okay, now you can check. How many carbons are there? 1, 2, 3, 4, 5. 5 carbons. How many hydrogens? Double. Should be double of this one. This should be 10. 3 to 5. 5 and 5, 10. And how many oxygen? 2. Sorry, 10 here. 10. Okay. So this is very simple. This type of question generally comes in examinations. X, Y, Z. So if we have 3 carbon, okay, let me practice this one more time. Let for example, you have carboxylic acid, and you have an alcohol. When they react together, carboxylic acid, and you have an alcohol. When they react together in the presence of concentrated sulfuric acid, it will gives you ester plus water. Okay, like if we are having this 3 carbon carboxylic acid, the general formula. Okay, and we are having 2 carbon alcohol. Then can you tell me that what is the compressed formula of this ester? Can you tell me the compressed formula of this ester?
C5H10O2.
Yes, C5H10O2. Simple. The 5 carbon compound should be there in the esters. Let's if I take that, if it is, you need to tell me that which carboxylic acid is it. If we are reacting this with 2 carbon alcohol and we are having 3 carbon carboxylic acid, sorry, ester C3H6O2. So can you tell me that what is the name of this carboxylic acid? Can you tell me the name of this carboxylic acid?
CH3OH.
Yes, this will be HCOOH. 1 carbon carboxylic acid should be there. And this will be methanoic acid. Because 1 plus 2 will give you 3. Just I'm coming back in a minute, okay? Now just it is you need to do this one, that what is the name should be given to this one. Please tell me the name of this ester. Just coming back. Can you tell me what's the name of this ester? So you know that this portion will come COO. Here is H. This will come from this. This means this group come from the carboxylic acid, and there will be two carbon alcohol is C2H5OH. So this will be C2H5OH. So this is, you can take C3S6. Okay, and the name for this one will be ethyl methanoate. Meth for one carbon, because this is methanoate. Okay, got it? Understood? Kiran,
Yes.
Yes.
Arfanur,
Yes, sir.
and everyone, Saima, Kiran,
It
Madiha,
won't be methyl
just,
ethanoate.
Yes, sir.
it will not be methyl ethanoate, because it will be methyl ethanoate when we have two carbon carboxylic acid and one carbon alcohol CH3OH. Then when you react it, you will get CH3COOCH3. This group will come from the alcohol, and you will write it name is methyl ethanoate. Okay, and they will have the same formula. Compressed formula is still the same. Methyl ethanoate and ethyl methanoate. They both have the same formula. This is methyl ethanoate. Okay. And if you write it like this way, CH3COO and then C2H5, this is ethyl ethanoate. Methanoate. Ethyl methanoate. Meth for one carbon. Here it is two carbon. So it is methyl for this group, and then eth for two carbon, and then OH. And ethyl for this group, and then one carbon is meth and OH CO for CO. Okay, this name. Now you understood. Is there any confusion?
No, sir.
Okay, depending on the type. In methyl ethanoate, we have, it is formed by methanol and ethanoic acid. And in ethyl methanoate, it is formed by methanoic acid and the ethyl alcohol, or we can say the ethanol. So here we have one carbon alcohol and two carbon carboxylic acid. In this one, we have two carbon alcohol and one carbon carboxylic acid. There is a difference. Got it? And you need to
Yes.
keep in mind, this is very much type, means many times this question is being asked. If you have two carbon carboxylic acid, two carbon alcohol, then it will be four carbon ester. So if it is given to you 2 plus something and you need to 5, so it is given 5, then it should be 3 here. The simple addition rule. Got it? Got it? Why not replying?
Yes, sir.
Let's to the next question. Next question was after 77, we have 78. Question number 78. Here it is, that which of the following chemical equations represent each of the following types of organic substance. So this is very simple, that esterification, and saponification. So write one chemical equation to represent each of the following types of reactions of the organic substance. So esterification, you can write anyone, that we were writing that C2H5OH, alcohols when react with carboxylic acid CH3COH, it will gives you CH3COO C2H5 plus water. Okay, ethanol, ethanoic acid, ethyl ethanoate. And saponification reaction is when esters react with NaOH. So let's take this reaction CH3COO C2H5. When it react with NaOH, it will give you CH3COONA. Sodium salt of carboxylic acid means this group and this group will make bond together, and this group and this group will make bond together. C2H5OH. So this is saponification reaction. This is very general reaction, that esters when react with sodium hydroxide, then it will gives you sodium salt of carboxylic acid, another. Okay, you understood? Tell me fast.
Yes, sir.
After 78, we have 90. Question number 90. Just look at question number 90. Question number 90. This question is in the two parts. So now you can check it on your screen. On dropping a small piece of sodium in a test tube containing the compound X with molecular formula. Do it. This the knowledge that we were using. Please, with the help of this one, please do try to solve this question. Find out the value of X here, X and Y. So it is saying that on dropping of sodiums in a test tube in a compound with molecular formula C2S6O, C2S6O, uh, a brisk effervescence is observed. Okay, and uh, and and a gas Y is produced. Okay, on bringing a splinter that the test tube, that it will burns with a pop sound, means indicating that the gas is hydrogen gas. Okay, if X identify the X and Y. Okay, gas you have to find out, and also write the chemical equation for the reactions, and write the name and the structure of the product form when you heat X. When you heat X with concentrated sulfuric acid. Please do this question. This is very simple question. And tell me what is asking. What is X actually?
X is ethanol.
Yes, X is ethanol. X is ethanol. How you see that alcohol, like aldehyde and ketone, has general formula? You see that alcohol has general formula, that is CN H2N plus 2 and then O. Means alkane plus O. This is the general formula for alcohol. Like we have C2H6 and then O. Like we have C3, double of this one, right? 8 and then O. This will be the propanol. 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 This is ethanol. Okay. If I'm asking that what is the formula for the pentanol? So C5, double of this one plus 2, 12, then O. This is the compressed formula for pentanol. And if it is asking aldehyde and ketone, because in here in alcohol we don't have a single bond, na? We have single bond everywhere. We don't have double bond. But in aldehyde ketone, we have in aldehyde and ketones, aldehyde and ketones, ketones. General formula is CnH2n H2NO. CnH2NO. That is alkene plus O. Alkene plus O. Okay, like for example, if I write the 2 carbon aldehyde, so 2 carbon aldehyde will be C2H4O. Here it is 6, but here in aldehyde it will be 4. If I ask you 5 carbon aldehyde, so it will be C5H10O. But in alcohol it will be C5H12O. Now you understood? Understood? Journal formula
Yes,
is
sir.
very important. Journal formula is very important. Okay. So let's do this one. The next one. Yeah. Now it is saying that this is an ethanol. So because it is 2 carbon alcohol and because its journal formula is same, alkane and O. So this is alcohol and it is C2H5OH. When you add sodium to it, it will gives you CS3, CH2ONA, ONA, or you can write it C2H5ONA. You can write it anyway. It is N plus hydrogen gas. They both are same and they have the formula named as sodium ethoxide. Oxide. Now you understood this one, sodium ethoxide? Tell me. Okay,
Yes, sir.
so X compound is ethanol. Okay, and even you can predict it with the molecular formula. In case of ester, you will not be able to predict that what is the formula, what is the name of this compound, because like for example, in the previous one we were doing that like here in esters you cannot predict with the journal formula. Okay, like this compound has two forms. This is C3S6O2. C3S6O2 and its name can be methyl ethanoate, and C3H6O2 it can be ethyl methanoate also. In case of ester you will not be able to predict, but in case of carboxylic, aldehyde and everyone you can easily predict. You can easily predict because there is no other chance. So if it is 2 carbon, general formula is alkane plus O. So it is simple that CnH2NO, CnH2n plus 2O, then it is ethanol. Simple. And you know that it is, you have studied these reactions. And now also write the chemical equation for the reaction. So you can easily write the chemical equations. You can easily write the chemical equation here and write the name and the structure of the product form when you heat X with concentrated. So what is the name? Tell me, when ethanol is heated with concentrated sulfuric acid, dehydration reaction will take place.
Mhm.
H2SO4. It will gives you the structure it is asking. So we will make the structure here and will be ethene plus hydrogen gas plus water. Dehydration reaction will take place when alcohol is added to. If it is 2 carbon alcohol, it will gives you 2 carbon alkene. Got it? Got it? Is there any doubt for this
No,
question?
sir.
No? Next question is after 77, 78, 90. We have 89 and 102. 89, 102. 89. 89. I think this question is very easy and you all will be able to solve this question. Write the chemical reaction for the sodium hydroxide and ethanol when they are reacting with the ethanoic acid. So you know that when sodium react with ethanoic acid, it will form sodium ethanoate. When it react with sodium hydroxide, then it will gives you sodium ethanoate and water because acid and base react together, they will form salt and water. And this will gives you ethyl ethanoate because it will goes esterification reaction here. Ethyl ethanoate plus water. You understood now, everybody? So all these three will be able to, you will be able to solve. May I consider this one? Should I move to the next question, please? Tell me.
Yes, sir.
Kiran,
Yes, sir.
Will you able to solve this one?
Yes, sir.
Yes, sir.
Okay. If
Here
you are
also.
having any doubt, you can check in the solution also. Okay. Because this is general reaction, that ethanoic acid react with sodium, because acid when react with metals, it will give you salt plus hydrogen gas. In case it will gives you salt plus water, and in this case it will gives you ester plus water. Next, after we have this one, then we have 89 and then 90. 90 we have done. 89, 90, and then 102 and 103. 102. It is an important question. Yeah, it is an important question, but it is easy. And I just want to say that most of the questions are just repeating themselves. Okay, and they are not the tough question. You can do it very easily if the concept is clear. Can you tell me that how this question will be solved? The structural formula of ester is this being given to you. Write the structure formula of the corresponding alcohol and carboxylic acid. And mention the experiment condition involved in obtaining ethene from ethanol. So can you tell me that alcohol and carboxylic acid of this one, of this ester respective? Tell me
Sir, the
carboxylic acid and
alcohol is ethanol and the acid is ethanoic acid.
yeah, it will be, which is 2 carbon alcohol, C2H5OH, and it is ethanoic acid, CH3COOH. Okay. And mention the experimental condition involved in obtaining ethene from ethanol. Ethene from ethanol. So ethene from ethanol, this is very simple, that when you have C2H5OH and you add concentrated H2SO4, there's so many times this question is being repeated. Nah? This will gives you ethene, C2H4 plus water. Experimental condition is that it should be added with concentrated sulfuric acid at 443 temperature Kelvin. Though this is very important that most of the student will forget this temperature mentioned, because if you just decrease the 19-degree temperature, or I think 19, yeah, 19 or 13 degree, so it will give you different product. This product, this is why therefore asking the experimental condition. So experimental condition is temperature is should be 443 Kelvin, and we should add concentrated H2SO4 to it, few drop of concentrated H2SO4. Write the chemical reaction for the above. You can write it.
Yes, sir.
We have written here. Next, after 102, we have 103, 104, and 110. 102, 104, and 110. Solve this one, please. Do this question, please. A carbon compound P on heating with concentrated H2SO4 forms another compound Q. Carbon compound P on heating with H2SO4 forms another compound Q, which on addition with hydrogen gas in the presence of nickel catalyst forms an saturated hydrocarbon R. 1 mole of R on combustion gives 2 moles of carbon dioxide and 3 moles of water. Find P, Q, and R and write the chemical reaction involved. This is very simple questions. Do it, please. Hmm?
Done, sir.
What is P?
Ethanol. Sorry,
Yes.
ethanol.
No, it is ethanol.
Oh yeah, ethanol.
So what is the role of this one? This one molecule of R on combustion gives 2 molecules of carbon dioxide. What does it mean? It means and 3 molecules of water. So it means that 2 molecules of carbon dioxide means that one mole when this hydrocarbon is burned. So it means that it is giving you 2 carbon or 2 molecules of 2 mole of carbon dioxide. It means that total carbon here will be 2 carbon. In this compound, we should have the 2 carbon. Whatever it will be when it burns. So it is saying that when you keep this one here 1 mole, then it will give you 2 moles of carbon dioxide. Got it? Got it? So you can write it in a very simple manner that this is 2 carbon dioxide. So it is a 2 carbon compound. Just means it can be ethanol, whatever it is, it should be eth. This is very simple that when a carbon compound P on heating with excess of concentrated sulfate, so this is H2, so it should be alcohol because you know that when you heat it at concentrated, again this same reaction is repeating. It will gives you 2 carbon alkene plus water. Okay, so this is compound P on heating with concentrated H2SO4 gives another compound Q. You know that it is an unsaturated hydrocarbon. So unsaturated hydrocarbon gives addition reaction. So Q on addition, which on addition in the presence of nickel. So now you have C2H4. When you heat it in the presence of nickel, palladium, and platinum, when you pass hydrogen gas in addition of hydrogen, okay, this will gives you an alkane C2H6, nickel, palladium, and platinum. Now you know that this is C2H4, this is C2H6. Okay, this will give you saturated hydrocarbon, and this is R. Now it is saying that 1 mole of R, when you have 1 mole C2H4, sorry, C2H6, when you heat it, when you burn it in the presence of oxygen, it will give you 2 moles of carbon dioxide and 3 moles of water. 3 moles means 3 to the 6 hydrogen. And here it is 2 carbon. So it is, got it? Now you understood PQR? P is ethanol, Q is ethene, and R is ethane. Understood? Tell me fast.
Yes, sir.
This type of question is being asked in the examination. Soap and detergent both are that soap and detergents are both type of salts. and state the difference between the two. So you know that soap are the sodium potassium salts of long chain of carboxylic acid, while detergents are the sodium salt of benzene sulfonic acid, that we have written in the notes also. To read it from there. Write the mechanism of cleansing actions. So cleansing actions that we have also written. Why do soap form lather in hard water? Because you know that hard water contain, like we have soap. Soap is,
Dissolved calcium and magnesium.
yeah, they form when they react, means because they soap are the sodium potassium salt of long chain of carboxylic acid like C17H35 COONA. This is soap, and it's hard water contain calcium salt, like we have calcium chloride or calcium sulfate, anything. So it will form C3H35COO whole twice, and then Ca, because you know that this OH ion has one valency. So whatever the hydrocarbon chain is it, if it is reacting with one, so one will form normal C17H35 one. But if we have calcium here or magnesium, then it will be 2, and this 2 is going to multiply with this bracket. Okay. So it is insoluble in water. Insoluble in water. So that's why it does not comes, uh, do not work, and it most of the soap uh, react with the salt that is present, calcium and magnesium salt present in the water, hard water. So most of the salt used there, so it does not form. Okay, understood? Mention the two problem arise due to use of detergents instead of soap. The two problem that it is not biodegradable. Okay, got it? And the second problem is that it has a very hard cleansing process. Okay, that's so it does not it is not suitable for means for using for means for washing the face and something, because there we don't require the hard cleansing. Okay,